Okay. So, we are back again. So, this is actually what we have seen. So, all steady state value of generation and delta p ti 1 all will remain same, only that 2 units earlier it was not under AGC, now it is under AGC, right. So, dynamic responses are shown in figure 5 and 6, right. So, in this case the AGC controllers have some effect on the transient behavior of the responses, but have no effect on the steady state performance, right. So, case 3, before going to case 3, let us go to this thing. So, this time if you look into that unit 1 and unit 3 are in your what you call are under AGC. So, peak deviation everything is same, but unit 1 and unit 3 it has your what you call that your AGC controller, right. So, that is why that and whatever gains other things are taken for integral controller and load following controller, I will give you later. Parameters whatever earlier I said it remains same, right. So, but it is frequency and other things all reaching a steady state, and that APF, that your AC participation factor also has effect on transient responses, but there is no effect on the steady state. Similarly, for your delta F2 also, right. So, it is also lot of oscillations, but ultimately it is going to steady state to 0, right. So, similarly, the tie power error you can see that lot of oscillations are there, right, when AGC controllers are there, but actually this gains and this thing some arbitrary value we took, right, actually not optimized, some arbitrary value. If you optimize, perhaps the response will be better. So, in this case your if you look into that actual also same thing is coming minus your 0.0115 per unit megawatt, your what you call 0.00115 per unit megawatt, and a steady state error is vanishing. This is 0, actually this is actually your 0 line, this is 0 line, right, this is actually 0 line. So, it is going to 0, right. So, only thing is that because of this controller and this thing AGC controller as well as APF, right, that only that transient behavior has changed, but steady state values remain same, right. Similarly, the generation also the transient behavior has changed, but delta Pg1 as usual it is coming to 0, because it is under AGC and there was no contact with any other discos. So, ultimately delta Pg1 as steady state it is generating 0 power, right, but during transient your transient behavior, but transient operation, transient time duration, right, it is some generating some power, increase decrease, but finally it is settling to a 0 as steady state, right. And delta Pg2 also as steady state whatever value was there earlier 0.0085 per unit megawatt. So, it is coming here, right. So, only thing is that responses that transient compared to the case 1, now the case 2 transient behavior have changed, right. Similarly, delta Pg3 and Pg4, delta Pg3 again it is going to your what you call the 0, because this is 0 line, as steady state is 0, and delta Pg4 is matching its steady state value, right. So, only thing is that because of AGC controller that your transient behavior actually changes, but steady state value remains same. Now, next one is that we will come back to this, that case 3, right. So, that responses which I showed that is for case 2. Now, case 3, in this case the role of the generating unit is the same as in case 2. The contacted demand of the discos, that is distribution companies, DPM and AC is participation factor are also same as in case 2. So, everything remains same, AC participation factor also remains same, but however, in addition to the contracted demand of 0.005 per unit megawatt for disco 1, it also demands an additional power of 0.005 per unit megawatt, which is uncontracted. That means, distribution company 1 its contracted power demand was total demand was 0.005 megawatt. In addition to that, it also want that 0.005 per unit megawatt, which is uncontracted, right. So, this I will skip because I have already explained, right. Now, that means that delta PL1 uncontracted is 0.005 per unit megawatt. Now, when an excess demand occurs that we have discussed earlier and which is not contracted out to any generation companies, right. the change in load appears only in terms of the area control error, right. Hence, the additional demand or shortfall of generation has to be shared by all the GENCOs of the area in which the contacted violation occurs, and the generation in other areas remains unaffected, right. Thus, at steady state, on the occurrence of an uncontacted demand, the unit generation given by equation 17 get modified to. So, first before this telling this one, that modification, I will go to that diagram once again. So, what happened in this case now, then we will go to the simulation, then everything then everything your what you call will be clear to you. So, in this case, that this your unit 1, that is this unit 1, and it was in area 1, that that uncontacted disco 1, that one has demand some excess powers, that is 0.005 per unit megawatt, right. So, and second thing is that your this unit 1 actually not under your AGC. So, that means this part should not be there. So, K 1 should be is equal to 0, right. So, keep K 1 is equal to 0, then in this case APF 2 for this case is equal to 0, and this value is equal to 1, right. So, earlier we have seen that when there was no uncontacted power demand, delta Pg1 was actually a steady state, it was 0. Now, this load following controller is not there for your unit 1, but your that is K1 0, but it is under AGC, because APF 1 is 1 and APF 2 actually it is 0 and it is under load following, that is unit 2, but uncontacted power demand has happened here. So, there are 2 discos in each area, that means I am writing here. So, that means delta PL1 UC dash, it actually it was 005 per unit megawatt, right. This demanded by disco 1, but in area 1 that PL2 dash UC equal to 0.0, that is I am making delta PL dash, right. That means delta PL1 UC, the total uncontacted demand, delta PL1 UC, right, is equal to this one plus this one, that is actually nothing but 005 per unit megawatt, right. I am putting dash, do not confuse, here also delta PL2 UC is there, that is nothing but delta P or what you call the delta PL2 3 dash UC plus delta PL2 dash your PL2 use delta your here it is making delta PL1, that is delta PL3 dash UC plus delta PL4 dash UC, right. So, there should not be any confusion. So, that means this delta PL1 UC basically 0.005 megawatt, but this unit, that is your unit 2, it is under your load following. So, this generation will this delta Pg2 will change this load. So, this unit will not generate that extra power 0.005 per unit megawatt, but this unit is not under load following, but it is under AGC and APF is 1, that means delta Pg1 will generate that will take care of that at generating additional power, and it will give it to the distribution company 1, right. So, at steady state in this case delta Pg1 SS it must be is equal to 005 per unit megawatt, because APF is 1 and this is 0. Even if you APF, suppose for example, if you make APF is equal to 0.7, then APF is equal to here it is 0.3, but it will not help to generate that 0.005 by this one. So, it will be a contradiction, because whatever is there generation that contacted power for unit 2, this unit 2 generation will change this load, right. So, in this case APF is equal to 1 and this thing APF 1 and your APF 2 is 0, and here no uncontacted power demand. So, in this case this thing will remain same. So, there will be no load following here, APF should be equal to 1, APF should be, this unit will be load following, right. So, I hope this has been understandable to you. So, that means I will go back to that case, right. So, just hold on. So, So, this I skip, I told you already shown for that case too. So, now that means thus a steady state on the occurrence of an uncontracted demand, the unit generation given by equation 17 get modified too. So, we write like this, that delta Pg1 steady state, delta Pg2 steady state, delta Pg3 steady state, delta Pg4 steady is equal to APF, that is AC participation factor, into the delta P1 dash UC means that is the uncontracted power demand, if any, demanded by DISCO 1, distribution company 1. Delta PL2 dash UC means uncontracted power demand demanded by DISCO 2, right. Then this is delta PL3 dash UC, that is uncontracted power demand demanded by DISCO 3, and delta PL4 your what you call dash UC, that is uncontracted power demand demanded by your DISCO 4, right. So, that means in that block diagram whatever we have seen, that in general that your delta PL1 UC actually is equal to delta PL1 dash, I told you this one, plus delta PL2 dash UC, right. Similarly, in area 2 somewhere I am trying to accommodate it, overwriting on it, delta PL2 UC is equal to delta PL3 dash UC plus delta your PL4 dash UC, right. So, these two has to be added, because all these things, right. This is for delta PL1 UC, for that is for area 1, and this is for area 2, right, if there is any. So, and this is actually AC participation factor plus whatever contracted power demand you have, delta PGC1, delta PGC2, delta PGC3, delta PGC4, this is equation 18, right. So, if it is so, that means that in the area 1, that distribution company 1 actually that demanded 0.005 extra power. So, this should be 0.005, right, and delta PGC1 contracted power demand, because it was not under load following. So, it was 0 and this was 0.005. So, steady state it will be 0.005, and this APF matrix I will show you, it is a diagonal one, APF 1 is 1, right, multiplied by that. So, same thing will come. So, just you have to put. So, what is AC participation factor? This is APF matrix I call, right. So, this APF matrix actually is this one. This is APF 1, APF 2, APF 3, APF 4. So, in this case APF 1 is 1, APF 2 is 0, and again APF 3 is 1 and APF 4 is 0. But in area 2 there was no uncontracted one, but APF 3 is 1, that means unit 3 is under AGC, but there is no load following. So, that load following controller, the value K3 will be equal to 0, right. So, that is why it is 1, this matrix is, this is 1. So, this is 0, this is 1 and this is 0, only 2 element non-zero elements, right. Therefore, delta, and it is I told you delta PL1 dash UC is 0.005 per unit megawatt, that is demanded by the distribution company 1, right, but all other delta PL2 dash UC is equal to all these things, delta PL3 dash UC, delta PL dash UC is equal to 0. So, if you use this, so therefore, if you use this this thing, this equation 18, then your delta Pg1 SS will be APF 1 into delta PL1 UC plus delta PGC1. So, delta PGC1 is 0. So, it is actually delta Pg1 SS is equal to 0.005 per unit megawatt, that I told you. Now, it may be noted that the generation of other GENCOs are steady state, that is delta Pg2 SS, delta Pg3 SS and delta Pg4 SS are same as in case 2, because if you use this formula all you will get, this is APF. So, this APF you put it here and multiply and get all this delta PGSS. So, you will get the same thing, same as in previous case. So, that means your delta Pg2SS is 0.0085 per unit megawatt, delta Pg3 steady state is equal to 0.0 per unit megawatt, and delta Pg4SS is 0.0115 per unit megawatt. Now, since as steady state the delta p tie schedule actually delta p tie 1 actual. So, delta p tie error also will be 0.0, but as some uncontracted demand is there and GRC is there. So, dynamic responses will be deteriorating, right. So, dynamic responses are shown in figure 7 and 8. So, when you come to figure 7, that a lot of oscillations are there in frequency deviation, but you see that at steady state it is 0, the deviation is 0. Similarly, for frequency deviation in area 2, right, that is also a steady state frequency deviation is 0, but some oscillations are there. And when that extra one other thing is that previous cases we have seen the peak deviation was what you call minus 0.08 hertz, right, but now in this case the peak deviation is much higher, right, it is much higher. So, here also same thing, right. So, because this has happened because of uncontacted power demand, right, and here also because of uncontacted power demand, if you look into that huge oscillations in tie power, your error as well as actual, huge oscillations are there, but at steady state that your actual power some steady state value will be there, we have calculated already, but dash 1 is error, but error will be 0 because this is a 0 line. So, error will be 0, right. So, that means uncontacted power demand also as soon as it is coming, apart for your contacted one, that dynamic response is actually getting deteriorated, right. Similarly, if you look into the generation also same case, but in this case you will see that delta Pg1 as steady state generating 0.005 per unit megawatt, right. So, this is your steady state, it is matching, right. It is actually scale is you can see and multiplied by 10 to the power minus 3. So, and delta Pg2 that unit 2 whatever power it is supposed to generate, so it is generating here, right. So, so already it is your what you call it is coming, it is up to 1/52 it was drawn, right. So, already whatever steady state value this thing it is matching. Similarly, for your what you call for delta Pg3 and delta Pg4. So, delta Pg3 also it is coming to 0, it is 0, and delta Pg4 also settling to its that is your 0.0115 I think, right, that steady state value as steady state. So, that means uncontacted power demand is taken care of by the unit which are in that area 1 which are under AGC, right. And another thing is you can examine of your own that suppose some uncontacted power demand is there and there is no integral controller, that means no units are in AGC, and just see that how things are, you can put it in Simulink also, no problem, what is happening, something will happen, right. So, why what it is, whether just check whether frequencies going to the steady state values or not, and delta P error also going to steady state values or not, when no AGC controller, but uncontacted the load following controller will be there, but no AGC controller, that is Ki1 is equal to Ki2 is equal to 0, right, and just see uncontacted power demand what is happening. So, next one is case 4, right. So, in this case it was in the case 3 actually it was seen that the uncontacted power demand in area 1 was made completely by unit 1, since it was the only unit under AGC in that area, right. However, if we desire, I mean if it is so desired that some portion of the uncontacted demand be taken up by other unit, that is unit 2 in area 1, right, assuming that it has some reserve capacity, that is your spinning reserve, right, then a different control scheme is required, and this control scheme actually is shown in figure 9, right. I will show you the figure 9. So, actually what happened, first you see this figure. So, first you see this, just let me little bit reduce. So, if you see this one, then in this case what will happen, that not as a whole it has drawn here, but I will go to the diagram once again. So, in this case if you see that this is my AC controller, right, for your that AGC controller for area 1 integral controller only minus Ki1 upon S, right. Now, APF1 and APF2 to your what you call that is your AC participation factor, but question is that this unit 1 is under AGC, but not load following. That means, if other things are not shown here, it will be huge. Then I will go to that once again to the diagram, I will tell you in detail. So, AGC, and in this case your what you call that load following controller gain was 0, and similarly in this case your what you call that load following controller is here, right. But this part earlier was not in AGC, but as soon as what we are doing is this APF 1, that AC participation factor 1, then APF 2 is equal to 1.0, right. Now, if we want that this unit will share say 60% of that total uncontracted power demand, right. Our total uncontracted power demand was 005 per unit megawatt, that demanded by DISCO 1. We want the unit which is under AGC, it should give 60% of that. That means, my APF 1 is equal to 0.6. That means, at steady state unit 1 should generate that 0.005 into 0.6, right. So, 0.005 into 0.6, that is 0.003 per unit megawatt, right. And this APF 2, suppose this is now 0.4, because this is 0.6, it is 0.4, total will 1. So, this 0.4 means that this unit 2, apart from your supplying its contracted demand, it should also your what you call generate this power for DISCO 1, right. So, that means the 0.4 into 0.005, that is 0.002 per unit megawatt. That means, in addition to its contracted power demand delta PGC is its contracted power demand is delta PGC 2. In addition to that, it should give this power, that is my say 0.002 in this case, right. So, how will conceive that? I told you in the beginning that this is that U1, that is your what you call that your that output of the controller. So, at steady state I told you generally what happen at steady state, that U1 value at steady state, it actually become your what you call that total power generated, right, by the your generator, right, because AGC controller. So, what happen U1 SS will be is equal to your whatever uncontracted power demand will come, right, that is that will be say in this case 0.005. So, as steady state, if you plot it, you will see that U1 steady state actually is showing 0.005. So, that is equivalent to your whatever controller output will come at steady state, that is equivalent to that uncontracted power demand. So, that is why what we have done is that that your this is my U1 in the area 1. So, a feedback is given here, that is take output of this one, that is here it is going actually here I am making it here, that it is APF 2 into U1, right. This is going, that means it is basically it is what it is coming delta PGC 2 plus APF 2 into U1, right. So, that means this generation delta PG 2 actually it will chase this contracted power demand this one plus APF 2 into U1. This is actually with the during transient this will change, but delta PG2C to contract it will remain constant because it is contracted power demand, but during transient it will change, but at steady state it will generate the additional 0.002 per unit megawatt, right. That means I will go back to once again to that block diagram, just because here only partially it was done. So, if you go to that block diagram here, right. So, in this case what will happen, that this is my this is my APF 2, right, and this is my load following thing. So, what will happen, that this is this APF 1 will be there, and instead of giving this one, right, you can put this one to here, this block, that is what has been done there. So, it should not be there, such that apart from this, and suppose this is 60.6. So, 60% of the your total power whatever uncontracted one will be generated by this GENCO unit 1, and apart from generating contracted power by generating unit 2, right, this additional uncontracted demand also will be supplied if the unit 2 has sufficient reserve, right. So, that is why this way it has been made, but load following controller is already there, right. So, this is actually for your what you call this additional thing, it has come. So, everything has taken together. Now, Now, if we take the AC participation factor, that APF 1, suppose if we take 0.8 and APF 2 0.2, that means that generation unit 1 will generate 0.004 per unit megawatt steady state, 0.8 into 0.005. So, 0.004, and apart from generating contacted power of unit 2, it will generate additional power, that extra, that is 0.001, that has to be added, and that should be the steady state. Now, with all other conditions remaining the same as in case 3, the uncontacted power demand in area 1 will be shared in proportion to the AC participation factor of the units in area 1. Then at steady state, unit 1 and unit 2 will generate the following power as equation 18, right. So, delta Pg1 SS, I told you, it will be APF 1 into delta PL1 UC. So, that is nothing but your 0.8 into 0.005. So, 0.004 megawatt, I told you. Delta Pg2 SS will be contacted power delta Pgc2 plus APF 2 into delta PL1 UC. So, 0.2 into 0.005 plus 0.0085. So, it is actually 0.0095 per unit megawatt, right. Note that at steady state, I told you U1 will be equal to uncontacted power. You can verify through simulation, although this plot was not shown, but you can verify. As in case 3, it may be noted that the steady state generation of unit 3 and unit 4 remains same, because we did not disturb any other thing in the area 2, right. And so, it is actually delta Pg3 steady state will be 0.0 per unit megawatt, and delta Pg4 SS will be 0.0115 per unit megawatt respectively, right. So, dynamic responses are shown in figure 10 and 11. Now, if you look into that this is delta F1 frequency going to your steady state, steady state is going to, the deviation is going to 0 values, delta F2 going to steady state going to 0 value frequency deviation, and type power same as before, lot of oscillations, but all these things it is matching, right. And if you see delta Pg1, right, delta Pg1, the dashed one, now generating 0.004 per unit megawatt as this thing, and this delta Pg2, apart from its uncontacted power demand, it has taken that 0.001 additional power. So, 0.095 per unit megawatt, right. So, that is happening here, because this, if you look at the scale, this is happening. Similarly, for your delta Pg3 and Pg4, so delta same as before. So, delta Pg3 is coming to steady state at 0.0, and delta Pg4 same as before, right. So, same values it is showing. So, this is your what you call that your variations of whatever is happening, that is during transient, but during steady state, at the time of steady state, all these things are becoming your what you call the matching to steady state values, right. So, only thing is that just I would like to tell that simulation thing we cannot do in the exam, right. So, only steady state thing. So, how formulas are given, how things are happening, everything you have to study. Thank you very much. We will be back.